Good afternoon, everyone, and welcome to this roundtable discussion hosted by REVOV, plugging into the future of sustainable energy. Today, we have on the panel Senior Economist Gaylor Montmasson-Clair, REVOV MD Lance Dickerson, and Tim Murray, who's from JNTM Solar Specialists. Today, we're going to be talking about the transition to a green economy and what the economic ramifications of that are. We'll also then be digging in a little bit deeper and asking, how does energy storage fit into this discussion? And Lance will take us a little bit deeper into second life batteries, and specifically how they relate to the broader topic. So without any further ado, I'm going to introduce you to Gaylor, who will kick it off and take us through his presentation. Gaylor, thank you very much.
Thanks so much, Devlin, and good afternoon, everyone. Really a pleasure to be sharing some ideas around the development of the lithium-ion battery value chain in South Africa. I work for an institution, TIPS, that's an economic policy research institute. It's based in Pretoria, and we do a lot of work with various parties to look at a number of key issues. And we've been doing work over the years with the South African government, as well as other partners, particularly UNIDO, but also the private sector, on a number of different topics, looking at the development of the green economy in South Africa. So I'll be providing kind of the overarching context, I guess, before Lance and Tim get into more of the details of it. The first really overarching thinking in terms of the transition to a green economy is it's really important to understand that the transition is underway. There's a number of dynamics that are at play. On the one hand, of course, climate change has not taken center stage, both in terms of the impacts that are being felt, but also in terms of triggering action. And then we've got a technology revolution with the fourth industrial revolution coming in. And like every transition, it is disruptive. It brings opportunities, it brings risks, but it has impacts. And what's really important to understand, particularly from a South African perspective, is that the question is not whether to transition or not. It's how successfully can we transition, because the transition is a global dynamic that's going to happen. And either we are proactive about it, and maybe we can have great benefits and minimizing some of the short-term trade-offs. But if we are reactive about it, then of course it's going to be forced onto us by our trading partners, by our financiers, and so forth. And the idea is really to try and maximize the benefits as well as minimizing the risk, but of course in line with our capabilities. We need to ensure that we have a just transition at the same time. That's not a transition that's only driven for those who have, but that everyone benefits into it. And that's just really kind of speaks to the fact that, of course, communities, workers, small businesses have a different ability to transition compared to maybe, big businesses and high-income households. And that's where, of course, public policy plays a big role. Within this picture, this overall framework, the role of battery technology is quite crucial. It is at the core of any kind of modern energy system, and effectively at the core of any kind of more sustainable economy and society going forward. It underpins the implementation of a smart grid as well as mini grid, so it's kind of more stable, resilient, affordable, and clean energy production, of course, hand in hand with the rollout of renewable energy, but also of e-mobility. And through the manufacturing, but also installation and maintenance of battery technologies, we can see huge opportunities for industrial development, for employment, and effectively also to drive just economic development in the country. And that can play, of course, through a reduction in inequality in terms of access to energy and so forth. So battery technologies are really core. They're not, of course, the only technology at the core of this, but they are one of those kind of key technologies and key developments that enable any kind of sustainable transition going forward. In the South African context, what we've been looking at is how to grow the value chain effectively. How can we get manufacturing in the battery value chain? And that's been quite of a key focus of the South African government and of the South African industry of late. Why is that? Well, it's of course because the demand for batteries globally is set to rise quite exponentially, primarily because of e-mobility, but also because of energy storage. Prices are going down, demand is going up quite rapidly, and what you find in any way is that the forecasts are on top of that quite conservative generally. But of course, from a global perspective, it's a relatively competitive space. China, as you can see from those graphs, dominates the space heavily, and then a few others are catching up, like Europe and the US, but also some of the other Asian countries. And effectively, South Africa, but also Africa as a continent, it does not feature at this point very strongly in that picture. If you look at the key companies, worldwide, you have a very similar idea. With a few companies effectively dominating the space, mostly from Asia, but also somewhat, from Europe and the US. And importantly, if you look on the right-hand side, that's a lot of announcements in terms of battery manufacturing. That's the sort of light green bars. A lot of announcements of late of a new capacity for producing batteries globally. And again, mostly in Asia, in Europe, in the US, but also to some extent in India, but not much, of course, on our end of the stick. But what about South Africa then? Can we have a strong role to play in that particular value chain? And that's the question that we've been looking at quite extensively. The first thing to understand is actually in terms of research development, we have quite a wide array of institutions domestically that work on those issues, and have been doing a lot of R&D. We are nowhere near some of our competitors in terms of competitive edge, and we can't compete just in terms of scale, but we've been pretty good at developing some skills that then feed into the private sector, and in some cases, even developing some relatively good IP, intellectual property. But of course, in the grand scheme of things, we are too small compared to the likes of China, South Korea, Germany, the US, and so forth, in terms of competing in that particular space. But it does provide a bit of a base for skills to be leveraged in the development of the battery value chain, the lithium-ion battery value chain going forward. If you look at mining, this is the typical kind of minerals that feed into a lithium-ion battery cathode. They have various chemistries, gives you an idea, but the key minerals are aluminum, cobalt, nickel, manganese, and of course, lithium. If you look at it from a South African perspective and even a regional perspective, what you find is that we actually have all of those minerals in the region. In South Africa, we're obviously very strong in manganese, but also titanium, nickel, iron ore, phosphate rock, cobalt, and copper. If you extend that to Southern Africa, then you have even more minerals. You have lithium in Zimbabwe, you've got nickel in a lot of countries, you've got all the minerals that are available. Of course, the question that we ask ourselves is, well, it's all well and good to have the minerals, but how do we move up the value chain to get into the beneficiation of those minerals and into the manufacturing of things? If you look at mineral beneficiation, we have quite a long experience in the country. But there's been little beneficiation of minerals to battery grade. We do some beneficiation of manganese and aluminium at the present, and we're also looking at nickel and lithium. But we could do a lot more. We do have some good examples. Very briefly, you'll get access to the slides. But some really good companies like Manganese Metal Company, but also Ulamin working on those kind of beneficiation in the country, but nothing extensive effectively. If we look at the manufacturing, what we find is that we have the industrial capacity and the know-how, but effectively there's no commercial production of battery cells. We have a pilot plant for R&D, but we don't produce the cells. They are all imported from Asia and primarily from China. However, we do have some capabilities, and particularly we have Meter, a South African company that does produce cells. They're just not producing cells in South Africa. They're doing it in Romania and in Turkey, essentially. There's some prospectors, but nothing concrete at this point. Where it gets interesting is of course the battery manufacturing. So of imported cells, then the assembly of batteries based on local components besides the cell. And here is a very vibrant space. We have a lot of companies operating, particularly they put together batteries based on their own technology in terms of the battery management system, the energy management system, and components that are sourced domestically, with, of course, the exception of the cells. Just some examples listed here that we can think of. There are many more actually in the country, and some of them have leveraged this to develop some niche vehicle offerings on top of that, which is quite unique. We also have some interesting development in terms of waste management. Of course, second life battery, the focus of today's discussion is something that we have in the country, and REVOV is a key player in that particular space. But when it comes to the total end of life, the recycling, then here we don't really have the capabilities at this point. We have the technical capabilities, but no recycling facility in the country. The space, as you can see from the graph, that is heavily dominated by China and most likely going to be further dominated going forward. The question is, what is our role in that space? We can play through maybe a pilot plant and some regional aggregation going forward. So what does it leave us, to have that state of play in terms of the country, in terms of way forward? Well, the things that we're working on is first important to find our competitive advantage in that particular value chain. It is very competitive globally. It is evolving rapidly, but there are a number of niche markets where we are displaying competitive advantage in the country. That's certainly in terms of the battery packs and some of the components, but also the beneficiation of minerals, which we have some really great capabilities. Of course, the mining is a natural advantage, but we are trying to move away from that. We need enabling policy support, and that's something that, of course, South African government is looking quite strongly at the moment in terms of providing a clear positive signals to the industry at all the stages, through funding, but also through issues around testing and certification, issues around the warranty, and the broader ecosystem around business development. Access to market is also another key issue that we are looking at, both domestically and on a global level. Domestically, it's about growing the domestic market, both in terms of energy storage and e-mobility. So the introduction, of course, of electric vehicles of various shape or form in the country, and how we play that out with an export strategy and access to global market, particularly probably through a partnership with kind of the large off-takers or large demand centers, be it either the utilities, power utilities, or the large automotive manufacturers, for example. So having those relationships is really critical for the development of the industry going forward, because most of the companies operating in the space at the moment in South Africa do so in a fairly niche market. And lastly, of course, skills development and R&D is critical. As I say, we have some centers of excellence, but we're not able to compete at global levels with the market leaders. But it does provide us with some skills and a pool of experienced people domestically. The challenge is, of course, if the industry grows rapidly, can we maintain that edge in terms of skills development? It might well become a stumbling block, or at least kind of an hindering factor going forward for the growth of the industry. So in terms of the developments going forward, what we find, just to repeat very briefly, is that the prime opportunities really are in the battery manufacturing, clearly, in terms of development of the value chain, and that's quite clear. We have lots of capabilities in the battery manufacturing, the manufacturing of components and parts. We want to grow mineral refining as much as possible based on the local minerals in South Africa, but also in the region. That's clear with manganese, aluminium, but also lithium, nickel, and maybe some others. Cell manufacturing is something to explore, but it hasn't been proven competitive yet in South Africa. There are some prospectors, and we yet to see if that can be done competitively in the country. There's certainly a number of supply side and demand side issues that need to be sorted out if we are serious about looking at cell manufacturing essentially for the African market going forward. Other markets have been taken up. And then in terms of the second life and battery recycling, we don't have the recycling capabilities at the moment, but that is something that also is being explored, particularly as there are stronger regulations coming in for the management of used batteries in the country that could spark some interest around a particular pilot facility. So in conclusion, really what we find is that e-mobility and energy storage are capturing increasing shares of the transport and energy markets, and that's coming with quite a strong demand for batteries. Lithium-ion batteries are currently the dominating battery on the market. We have some interest in other technologies in South Africa as well, like vanadium-based batteries, but certainly lithium-ion batteries at a global level are dominating. It shows in South Africa that we have quite a vibrant value chain at various levels, certainly mining, beneficiation, cell research. We've got battery assembly, we've got second life batteries, and we've got quite a lot of activities in the market. And we need to really put the emphasis on those trends to really support the development of the industry going forward. And this is some of the issues that we have put forward in terms of the policy signals that need to be sent to the market, but also to industry, to ensure that really we have an electrifying opportunity ahead of us, and that we don't just remain on potential and aspirations going forward. You can download a full report of our research through the link, and I look forward to further discussion and engagement today. Thank you so much.
Gaylor, thank you very much for that. Greatly appreciated. And I'd like to extend an invitation to the participants. If you go to the bottom of the screen, you'll see a little block that's called Q&A. Natasha has already alluded to it. If you have any questions, any follow-up that you'd like from Gaylor, please feel free to pop the questions through there, and we'll address them towards the end of the event. And the same holds true for anything that Lance or Tim will also discuss. Going forward now, I'm going to introduce Lance Dickerson. He's the MD of REVOV, and he's going to take us, bring us a little bit more focused inwards to the second life battery. Lance, without any further ado, I'm going to hand over to you.
Thank you, Devlin, and thank you, Gaylor, for that very insightful presentation there. And it helps me to kick me off when you talk about the transition being underway, and it is totally underway. And the center of this transition being the storage of electricity. And we identified this, but we also identified that the storage of electricity cannot be at all costs. And so everything that we decided we were going to do in our business had to be part of the circular economy as much as we possibly could. And hence we sort of moved into what you identify as the second life category of lithium batteries. I've got a couple of slides here just sort of running through what exactly second life is and what does that mean in the system. And what a lot of people don't necessarily understand is that second life batteries have been produced by the repurposing of EV batteries. So an EV battery inside an electric vehicle doesn't have more than about 1,800 charge and discharge cycles at the moment in the vehicle. There's a lot of work that's going on to extend that. And so the life of a battery in a vehicle will start to extend over time. But the biggest problem is that as the capacity of the battery starts to reduce after every cycle, eventually the battery just simply becomes too heavy for the vehicle, and the vehicle can't perform in the way that it was designed to perform. However, there's nothing wrong with the battery. It's just that the performance of the vehicle is not optimal any longer. And the batteries typically are designed for a 6,000 to 7,000 cycle life. And that life expectancy is actually in an electric vehicle and not in a storage application, which is quite a big thing. And we'll actually get into that a little bit later. In a storage application, as long as the weight and size is not an issue, a second life battery is very, very suitable to going into storage in solar, wind, or any kind of standby application. The second life batteries typically are still about a third of the weight of a traditional lead acid or AGM type of battery, and about a quarter of the size. So they're still a lot lighter and a lot smaller in their second life configuration, but from a size and weight point of view, they can't really compete with a brand new battery. However, from a performance point of view, they in most cases can actually outperform them. And we sort of, it takes a little bit of thought to kind of understand why do we think a battery that has already gone through nearly 2,000 cycles in an electric vehicle in quite harsh conditions, why do we think that can come out and be able to outperform in a lot of cases a battery that was designed specifically for stationary storage? And the answer is quite simple, that these electric vehicle batteries are designed in accordance with automotive standards. Now, an automotive standard means that something has to endure a 20-year life. It's actually, the automotive standards that are used today are actually more stringent than the typical mil-spec standards are. The battery is specifically designed to withstand vibrations and high temperatures and high charge and discharge currents, which are typical in the motor vehicle. All of this while we're trying to optimize this time versus distance versus speed versus cost and versus whatever. But typically, when you take out a battery out of an automotive vehicle and put it into a backup storage situation, you're typically looking for the battery to be able to provide you with 4 hours of backup, at least, or possibly more. And what this translates into is that often the battery is only being used at about 1/10 of its maximum output. Now, we all know that if we drive our motor car with its engine at 6,000 revs all day, it's not going to last very long. But if we drive it in its sweet spot at about 2,000 or 3,000 revs per minute, the life of the engine is going to be far improved, and the efficiency, the fuel consumption, etc., is way better. It's not dissimilar in this case, where we're taking a battery that was meant to be run at 100%, and we're actually only running it at 10 to 20% of its ability and its design capability. This reduces the stress and provides the same lifespan as a new storage battery, or a battery that was produced specifically for storage. And this is what makes Second Life such an exciting prospect in this economy where we just simply have to find ways to extend the life of everything that we use and take it in and not reuse it, but repurpose it and put it into a situation where it wasn't necessarily designed to be used, and it can be used quite well and very well in those circumstances. So, what does Second Life mean in the storage senses? For us, it's quite important that Second Life batteries come in different shapes and sizes. every car, every vehicle, every model, as you can imagine, has a different shape, a different size, a different density, battery or series of batteries packs within the vehicle. And when you take these and you start to unpack them, as we do, you can literally build almost any size and shape battery that you require using the basis of a second life battery and the cells which come out of the electric vehicle. Most of these are 12-volt cell configurations, so the immediate place that gets looked at is the 12-volt market. The replacement of lead acid has now become a reality in the 12-volt sector, where it's very easy to build a 12-volt battery that is in the same format as a lead acid and becomes what we like to call just a drop-in replacement of the lead acid. However, those 12-volt batteries also only have a limited application, and there are often imbalances and capacity issues within the batteries that come out of the vehicles. And so it is never ideal to take a battery directly out of the vehicle and reuse it as it is. We take them out, we unpack them, they get tested, and then they get repackaged into the formats that are required, which are 12 volt, 24 and 40 volt, 8 volt mostly. And then we also package them right up into the 800 volt range for medium to high voltage applications in large installations, which is that's the sort of growing part of the storage, where the amount of copper that gets used, the currents that run around in these systems, that kind of stuff is a lot easier to handle if we start to push the voltage up. And we can do that quite reliably now using second life. There's often a very big misconception between second life and second hand. And there's quite an easy way to explain it, but we always decided when we started the business that the business was always going to be about second life, and that's always going to be our primary focus and our primary product as well. Second life is only engaged when the purpose is changed from a primary source of power to a secondary source of power. When the battery is in the electric vehicle, it is a primary source of power. When we take it out, it becomes a secondary source of power. This means that the battery has been taken and put into a totally different application to what it was designed for. Second hand, on the other hand, means you take it out of the vehicle and you put it into another vehicle, and just accept that the performance is not as good, and it gets reinstalled to provide the same function as before. So quite a big distinction that we like to just try and put out there is that there's a huge difference between second life and second hand, and certainly the performance you can expect from a second life versus a second hand battery, where it was originally meant for storage and has just been put into another environment where it's carrying out the same thing. Of course, a lot of the questions we get is, how can second life lifespan be so good? How can we so confidently stand behind a 3,500 cycle warranty over a 10-year period, or whichever comes first? How easy is that to do, and why do we think that second life is so reliable? And besides the fact that we are now going into our 6th year in this journey, and we're well over 20,000 second life battery packs that we have repackaged and sold into the sub-Saharan market, most of those into South Africa. As I mentioned before, that in a second life application, the battery has a reduced stress. We receive every single cell with a history from a vehicle BMS. We know exactly where that cell has been. We know the conditions it's been operated in, and we can very, very easily predict its lifespan going forward. They are designed with a 7,000 or 8,000 cycle life as a primary source battery in a vehicle. When we now reduce the demand on that vehicle to a 10th or a 20th of what it was designed for, it's very easy to see how the battery life can be extended, and it's very easy to stand behind the 5,000 to 6,000 additional cycles that will be met by the battery. And then, of course, a lot of what Gaylor was saying is in the energy arena here in South Africa is we're starting to, and we all feel it, run into this energy crisis. And the core of this energy crisis has got to be renewable energy, and the core of renewable energy has to be the ability to store renewable energy over the long term. And so Eskom, in the way that Eskom is performing at the moment with the load shedding, it's not difficult to see that a 10% reduction in availability of power over the last 5 years is not going to take 5 years to correct. It's going to take 10, possibly even 15 years to correct, because it's simply much easier to break something down than it is to rebuild it. And so the load shedding issue, or the not necessarily the load shedding issue, but the ability of Eskom to provide power versus the demand is certainly not a short-term issue, and so we can't really have short-term solutions. Even the interim solutions that Eskom have put in place in their power ships, 20-year contracts estimated at 200 billion rand, just doesn't speak to anything that makes any real sense, certainly in terms of renewable energy and the drive to try and improve the environment and reuse. We've also seen, of course, that COVID has caused a huge issue with the movement of people, and suddenly the requirement for electricity during the day in different parts of cities, etc., has brought in a huge demand for energy storage and alternative energy supply. And if you looked at those graphs that Gaylor had, where we sort of looking at the second life cost of batteries, probably coming down in the next 2 years to around the kind of $50 per kilowatt hour mark. There's just really no other way to foresee any other way of really good, profitable and sustainable energy storage going forward. And the new batteries of the world are going to get eaten up into the electric vehicles simply because of demand. And we foresee that in the next couple of years, the only way of storing electricity and batteries is going to be via second life product range and via second life strategy. So I hope that's gone some way to just kind of illustrate where second life fits into this circular economy, and how we see it as going forward, and how second life can really change the way people deal with electricity and deal with outages, and supply their own demands going into the future. And so, yeah, thank you, Devlin, for the opportunity, and Gaylor for the opportunity to put this forward. And if anybody has got any questions, please feel free to type them up. We'll try and answer them as soon as we can when we get to the end. And yeah, feel free to contact us regarding any second life application. Thank you very much.
Wonderful. Thank you very much, Lance. That certainly went into a good amount of detail, and I can foresee some questions there. I already have one coming through, but we're going to deal with that once we get to the end. What we're going to do now is we're going to move to Tim Murray. As I mentioned, Tim Murray is with J&TM Solar Specialists, and Tim is going to kind of drill in even more and talk to us about second life in the field and the applications thereof and the usage thereof. So, Tim, I'm going to invite you to come on board and just chat us through a little bit of your experience out in the field.
Thank you, Devlin. I hope everybody can see me. I won't be able to speak as eloquently as Lance and as Gaylor, But basically, I'm from J&T Solar Specialists. We've been using REVOV batteries, the second life batteries, for close on 2 years now. We basically went out on site and actually had a client give us our first REVOV batteries, which was practically, I think, from the very first container that was actually brought in. They were KTM batteries, which was the old plastic orange and black batteries that were originally brought in. We were AGM people, so we used AGM batteries, and that was what we stuck to at that stage. We started using the lithium batteries, these second life batteries, as they call, and we were so impressed with them. The batteries are phenomenal. You get absolutely, there's no comparison between them and basically an AGM battery. So we really got good results when we started using them. Fantastic battery. With a bit of work, we actually went through the whole thing, got to know Lance, got to know the company. We went through this whole situation, so we've been with them for almost 2 years. We haven't looked back. We've basically been using the second life batteries in all our installations. From small to big, we've used them with any inverter that can basically take a voltage and that you can actually feed a voltage and tell what the voltage needs to be. So it's a very good second life battery, and it works very well. Okay, so basically, sorry, let me just check something here.
Great. While Tim just deals with that technical glitch there, Lance, I'm going to go into the first question here. The question is around the automotive standards and transferring that. Would you be able to go into a little bit more detail of why that automotive, what is it about that performance that makes sense from a storage battery perspective? I think that there was just some clarity wanted there.
Yeah, sure. So the automotive battery or the automotive cell is typically manufactured to withstand and operate at much higher charge and discharge rates in comparison to a standard storage battery. You'll see that a standard storage cell in the lithium environment is typically manufactured to perform at 1C. You'll get them that are manufactured to perform at more than 1C, but then the price starts to get driven up quite substantially as those parameters start to get exceeded. Now, the typical automotive battery is manufactured to work at 3 or 4C, and when you then reduce the strain on the battery and let it operate at these lower charge and discharge rates, the life of the cell is actually extended by that, because the cell is able it's manufactured for a life of, say, 7,000 cycles, but at 3 and 4C type of standards. When you bring it down to the 1C type of side, it extends the life substantially from that point of view.
Wonderful. Thank you very much there, Lance. I can see that we still don't have Tim, so that's fine. I'm just going to jump onto a question that we had for Gaylor. Gaylor, if that's okay. Over here, the question is, what would you like, or what would you envision as the ideal next step from like a sort of all the stakeholders' point of view, but starting at the top? What is the ideal next step in this discussion? Does it involve regulation? Is it activism? Where does that sit?
Yeah, I mean, look, thanks for that question. I mean, I think the next step really is to kickstart the market, and to do that, you need to unlock the potential of both the energy storage and the e-mobility. So on the storage side, it's got to deal with regulation, clearly. I mean, you need to be able to unlock that potential, both for small-scale embedded generation, just make it easier for people to go and install their own system, for communities to do that, but also even medium-sized systems. Now the burden to go ahead as a company to put a system, it's quite large for any system above 1 megawatt. So now the regulations are likely being pushed to 10 megawatt in terms of facilitating that. Actually, the private sector is pushing for a limit of 50 megawatt to say where you wouldn't need actually approval and a license from the regulator to do that. We're likely to see that stay at 10 megawatt, I think, for the foreseeable future. But certainly, what we need is a regulatory framework that enables anyone who wants to invest in a system to be able to do so. And then on the mobility side, we need to kickstart that market. We have in the country today, if you count all electric vehicles, even the mild hybrid, we have about 6,000 in the country. It's extremely small as a market. So we need to kickstart that demand for all type of electric vehicles. And that comes with an enabling policy framework, particularly some tax stamp changes to make sure that the brands, they bring the vehicles into the country and that customers are incentivized to buy them effectively.
Wonderful. Thank you, Gaylor. And on that, I think it's probably fairly related. Another question has come through here, and I presume that it would lean towards Lance. Where do you see the biggest demand? Is it from renewable sources, or are you finding that the crisis that obviously we all experience, that lithium, the demand for it is coming from a kind of UPS or protection from an unreliable grid perspective?
Thank you, Devin. Yeah, good question. We honestly see it's a dynamic thing. So we see it lean towards the UPS type of environment when we have load shedding problems. And so that becomes the priority of the immediate customer and the immediate requirement. But that is a very short-lived thing. Within a week after or 2 weeks after load shedding has stopped, we start to see already the transition back towards where people are actually building solar systems and wanting to add storage to the solar system. Of course, that storage adding to the solar system has also been driven by the load shedding issue, because a lot of people, have a solar system already, and then suddenly they realize that they don't have either sufficient storage or any storage at all to provide power during the evenings. So we definitely see it kind of sway between the two. But I do think we see about a 60-40 split, where about 60% of the stuff is actually going into solar type environments, or where there's a component of the installation is solar, and about 40% is pure UPS type backup, for want of a better word, than UPS, but just plain storage and backup power for emergencies.
Sure. No, thank you, Lance. That makes sense. But then just also, I actually received a message via WhatsApp now from someone who's watching this. They couldn't access the questions. Just for clarity for everyone on the call, people who aren't technical experts, right? So you've got a solar panel or you have a turbine. Where does the battery, how does the battery on a very surface level fit into this? Because we all see the solar panels everywhere, but why are we talking about lithium ion batteries?
So the panels, the wind generators, etc., are there to provide and to generate electricity when the conditions are right. When the sun shines, a solar panel generates electricity. When the wind blows, likewise for a wind generator. And unfortunately, the sun doesn't shine and the wind doesn't blow 24/7. And so really the battery is there to smooth out the delivery of the power by storing the peaks that are generated by the sun or the wind, and then delivering them when there's a trough in either of the two, or after hours once it becomes dark in the solar point of view. So really just taking and over-dimensioning slightly not slightly, but over-dimensioning the actual generation part, then allows you to store the electricity and then use it in the evening when the sun is not shining or the wind may not be blowing. That's as simple as where it fits in the solar and the regeneration.
Thank you, Lance. Thank you for that. A question that came through for Gaylor now is that he spoke about skills and an acute skill shortage. And I don't think that's necessarily unique to this industry. I mean, we're finding that across industries in the country and on the continent. Gaylor, do you think that, the solve for that is from a kind of import or borrowing of skills? And frankly, do we have the time for a bottom-up approach in the country? What are your views on what would be the sort of fix to our skill shortage in the country?
Yeah, thanks for that. Well, look, I think we have a great base in the country, and I think that must be acknowledged. I did show that one picture was all our kind of research and academic institutions really working in that space, and also many actually private companies doing their own training. So I think as it stands, we actually have a pretty good skills base in the field. The challenge, of course, is can we grow that skills base as the industry expands? We know it's notoriously difficult for people to move into South Africa, and I think that should be eased, definitely. I think it's not specific to the industry. I mean, I think it should be eased, and we want to attract skills into the country, and that's got to do with the visa regime. That's pretty simple. But it shouldn't deter us from saying, are we building the good skills domestically? And I think we actually are in a position where we are doing fairly well at the moment in that particular space. The issue is, can we retain those skills? Can we prevent from the people going into other industry, or of course leaving the country? And can we keep up? Can we keep up as the industry grows? Can we make sure that our universities, our TVET colleges, our training centers keep up with that growth? And at the moment, we are better. It's a fork in the road, really. We need to go the right way, grow the skills, make sure that the curriculums keep up, that we train the right skills to position ourselves domestically, but also actually potentially as an exporter of skills in the regions, certainly. But it is quite an important moment at the time, and we could fall behind if we don't keep up. So.
Thanks, Gaylor. I mean, that's promising, and the not falling behind. It's also ominous. It just means you've got to keep the finger on the pulse. We can't let this slip. This next question, I mean, whichever panelist wants to pick it up, it's wonderful. Talking about the circular economy resonated. So the question is, here I am as an average citizen, what can I do to be part of the circular economy, regarding energy? Lance, Gaylor, does anyone want to pick that one up?
I'm certain that Gaylor is going to have a lot more to say about it, but I'm quite passionate about it, so let me in. I think that it's not necessarily only the energy economy. It's not necessarily any one specific area. I think the thing is that we managed to find something that was able to enter a second life, and there are many more things that I'm not smart enough to figure out, but there are millions of other people out there that are way smarter that will figure out. And we need to find these things that we can take and adapt and push them into a second life application, and not just reuse them in their same applications. And I'm not sort of punting for us to take second-hand cars and push them until they're 40 years old or whatever the case, or 50 years old or whatever the case is. But there are many things out there that can be reused in a second life application and in another application where their life can be extended as opposed to their life being ended. And I know that there are many of them. I've happened to be able to find one or two of them, but I'm sure Gaylor will have many more ideas, and I think there are lots of people out there. And that's where I think the opportunity lies, to actually give back what we've taken, and certainly my generation, not necessarily you guys, my generation has taken a lot out of this planet. And if we can give back, and we can all give back in a little way, being creative, I think there's a huge opportunity in not just making a living, but also in improving a living. for everybody else that's out there. But that's my view on it.
Yeah, maybe if I can just jump in quickly. I mean, the circular economy, of course, is it's the economy. There's only one economy, so it's really looking economy-wide and society-wide at changing the way we do things. We tend to move from a very linear way in terms of what we say, cradle to grave. We produce, we use, we dispose, and we need to change this. And the thinking is kind of cradle to cradle, if you want. You produce, you've used, but you're going to now reuse in a similar way or a different way, or in some cases, of course, you're going to use it into the production process of something else. And you can find applications in every single sector, literally. Of course, in energy, that's clear, in the battery space. But you go to any waste product that you can think of, I'm not going to lie, 99.9% could be an input into the production process of another sector or another company. And that's true, in the food industry, it's true in the the plastics industry, it's true in all the metals industry, and so forth. And so that takes place at the individual level, of course, through reuse and recycling. But we also have to acknowledge that for it to take center stage, we need the scale, and the scale is going to come from business. That's where you're going to get the scale. And so of course, as citizens, I think it's important to do our little bit when it comes to limiting our use of product, reusing, recycling. But then it's also through changing behavior at wherever you work, at the workplace, in society, saying, what about doing things differently? Because that's where you're gonna get the scale, and the applications are endless. People don't know, but a lot of our roads are based, for example, from waste products. That's the N3 in South Africa is based on what is known as a waste product of a steelmaking process, for example. I mean, it's there are so many applications, and every industry you look at, you'll find applications like this. So it's just important actually to do one's bit, and then push for change at the corporate level, and I guess at the societal level as well.
Wonderful, thank you, Gaylor. You see, I always find this that this topic becomes very inspirational, and you kind of, and I think that's the point of this, is that if there can be a small activist in in each one of us, that we can make that kind of an impact. We are out of time, so I'm going to make an offer to all the attendees, especially the media that are on the call. If you have any follow-up questions, and if you want to know any more depth from Gaylor, I'll put you in touch. If you'd like to know any more from Lance, specifically around Second Life Battery and their applications, please feel free to contact us. You've got Natasha's contact details, and we can take this discussion further. But I'd like to take the opportunity to thank you, Gaylor. Thank you very much for the presentation. Gaylor shared the link to the full research in the chat section of the webinar. I encourage you to have a look. And then also from REVOV's perspective, thank you very much, Lance. I particularly found it exceptionally enlightening around the actual technology behind Second Life. So thank you very much.
Thank you, Devlin, and thank you, Gaylor. Thank you, everybody that took the time to log in and stay logged in. Thank you very much. I really appreciate it.
Thank you so much for the invitation. It was great.
Good.
Thanks, guys, and thank you to everyone. And that's a wrap. And remember, our call to action is let's find an application for Second Life everywhere where we go. Thank you very much. Goodbye.